So was that moment preparing live stream. Is it working? It's a small group today. Thanks for joining. Okay, that looks good. Okay, welcome to Neuroccino today in a small edition because most of the team is in Wales learning neuroanatomy. And I thought I'd use this occasion to present a paper on neuroanatomy, given that I was away last week to teach the neuroanatomy course here in the Netherlands, and now half the team is in Wales doing the visceral mind course. Rules of the game, very briefly, anyone is welcome to join us and present a paper. Just let us know beforehand. And then we discuss it to the best of our knowledge for about half an hour in total. Now, I'm gonna share today's paper, which is all about the cerebellum. Now, the cerebellum has been neglected for the most part, to the point where it's not even in many brain templates that we use. It's often just cut off. And it was for a long time thought to be involved in motor control, be the motor control center and tuning our motor function. And with more and more neuroimaging and clinical data, this has now been changed and is suspected to be involved in functions related to sensory motor processing, autonomic functions, cognitive functions, and emotional functions. So the small brain seems to be doing quite a bit. Now, let me share my screen and move you guys out of the way. Here we go. Now, I found this paper yesterday and thought it was quite exciting. It's a preprint at the moment, and you'll see why that matters later on. And if I switch to the paper, you can actually see, oops, sorry for the scrolling. Here we go. The human cerebellum, a digital anatomical atlas at level of individual folia. Now, this paper is very much based on this paper in PNAS, called The Human Cerebellum Has Almost 80% of the Surface Area of the Neocortex by Sereno, and you will see that Martin Sereno is also an author on this new paper right here. Now, they teamed up with Jeremy Schmahmann, who is well known for his work on the cerebellum. And if I dive into the paper, the idea is that we've underestimated the cerebellum for quite a while, only given it credit for its motor control functions. But as I mentioned, neuroimaging and clinical data has shifted that appreciation a little bit towards sensory, motor, cognitive, emotional, and autonomic functions. And they say that we had good atlases in the past, but this is the first one that is high resolution. So we're talking 0.16 here. And a digital version of the cerebellum that is labeled by an expert, even though in the paper it doesn't disclose who it is, but I have an idea to labeling, or at least check the labeling. And in total, the new atlas has 815 parcellations. Now, they say that it's important to have an atlas like that to refine the cerebellar structural and functional relationship, and also to quantify its inter-individual variability. Now, I got extremely excited about this and thought it was part of the paper, but sadly it's not. So for the whole paper, reading it, I'm like, what's our N here? How many people are we talking about? Turns out in the discussion, I think even in the limitation part, it states that it's one brain only. Now, this group knows the pros and cons of using a single anatomical specimen, still alive, but you know what I mean. to study history. Now, there's a beautiful short section about the history of cerebellar atlases, stating that this one here was the authoritative atlas for about 40 years. That was from the 60s, and then the Talaric atlas gave us a reference space, a normative space, but there was no information on the cerebellum. So the first atlas where the cerebellum was dropped. Then Jeremy Schmahmann published an atlas in 1999 and then also updated it in 2000, where it was for the first time available in the MNI, Montreal Neurological Institute space. Now, they also clarified and simplified the nomenclature in this publication. And there's various other atlases that have been based on other methods. So you have a lovely overview of a couple of critical references in the field. Now, as I said, they state that as useful and transformative as these atlases have been, there is no available digital cerebellar atlas with resolution fine enough to capture Folia level structures that encompass both volumetric and cortical representation. So that's what they provide in this publication. And here they just speculate about some of the potential uses that this atlas can have. As I said, they identify 32 regions and subdivide them into 815 parcels. Now, what I think is a shame is that we have no information on the deep cerebellar nuclei or the white matter of the cerebellum. So that I would see as quite a limitation. Here's the labeling they used. This was the first time where I'm like, how many people are we talking about here? And I looked at this labeling, and the cerebellum, I'm always struggling with a little bit in terms of the anatomy, just because we don't get to study it as much. But there's more and more critical literature coming out, also for language function, for example. And in terms of the anatomical definition, we just uploaded 2 videos on the channel that I will link later on as well. But I went back to a reference in Nature Neuroscience Reviews from 2009, where this was the anatomy, and I couldn't quite match that existing anatomy from the review paper to this anatomy, partially because I'm missing the first vermis sections or regions, which are still here. So that's a bit I struggled a little bit with, but I also have to admit that I didn't dive deep into the nomenclature, why it was changed, what has changed, and where they actually converge and diverge. But that is just to make you aware of that, and also drop in another reference that you might want to look at if you're interested in the cerebellum. Now, looking at what they did, here is the methodological overview as a figure, which I thought was quite neat. So they started with the Sereno atlas, created a virtual surface, then manually labeled the surface and applied some smoothing and correction, and then went from volume to surface, again another smoothing step, and also another semi-automatic labeling step. And then they parcellated that surface into 815 non-overlapping parcels that are of equal size. Now you can find the specific details on how they did it. At times I wasn't quite clear how it was done, but it is still a preprint, so I guess that will be a lot clearer once the paper is finalized. And let's go to the results. So this paper, I realized reading it, doesn't have any statistics in it. This is the results. So they basically just show the labeling, the individual lobes and how they are divided, and the resolution of the data. And that is pretty much it. Then they just give a brief description of the labels and the anatomical specificity. They also provide just a normal surface, the inflated surface, and a flat surface. Again, I lose orientation on the flat surface of the brain. It doesn't get easier with the cerebellum, I have to admit. Always a bit lost with flat maps. But you have it all available, so you can choose the one that you need. And that is it. Then we're already going into the discussion of the atlas, which is quite neat. And they, again, speculate about the different usage of an atlas like that, which for a start is 3D rendering, so you can study the anatomy. The segmentation of the cerebellum in a single individual, so you can morph the surface of the atlas to the individual space, and also map the topography of cerebellar connectivity later on. Now they dive into two, I talk like ChatGPT. They look at two problems that were specified before in the two Schmahmann publications from the late 90s and 2000, where they note a problem of the vermis, stating that there's no true vermis in the anterior lobe, which is, I guess, where I saw the discrepancy with the review. But again, I would need to go and dig deeper a bit into that original paper to see where the difference lies. But they conclude that the vermis is morphologically distinct in the lobes 7 to 10, which is what they have labeled. And then the second issue they briefly discuss is the definition of the cerebellar lobules according to the arrangement of the cerebellar fissure. Now they conclude, they go through the history of the Basel Nomina Anatomica, which is the authoritative nomenclature of anatomy, and how things in the cerebellum were labeled in relation to the cerebellar fissure, and then draw their own conclusion, which they also nicely summarize later on. And here is the point where they, for the first time, indicate that it's a single brain, and then only here in the limitation state that we're indeed looking at a single brain. As I already mentioned, in terms of the limitations, the nuclei and the fiber tracts have not been mapped in this atlas. It is a single brain, which has advantages and limitations. And the data should be available. Unfortunately, I think I jumped the gun a little bit, because when I use the link, you can download this file, but in there, all you have right now is a JSON file and not the actual parcellation. So I'm afraid I won't be able to show you the individual parcellation of the paper, but I guess that is going to be uploaded as soon as the paper is published. And that is all I have. Happy to discuss. Lilith.
Yeah, so thank you for presenting. It's really interesting. I didn't quite understand the reasoning behind those parcellations. So why there are 815 or 814, right? So is it a architecture or based on what?
So that was one of the questions that I noted on the side as well, that I wasn't quite clear how they derived those labels. So part of it is expert labeling, as they call it. And part of it is, let me see if I can find the term they use quickly. Where is it? Can't find it quickly. But yeah, they state that is an expert annotated anatomical ground truth. So I'm afraid.
But at the same time, it's not coinciding with regions from previous literature, or
some of
because
the previous literature. So I recently read that review paper in Nature Neuroscience, I think it was, in preparation for the anatomy class and to get an overview, because the cerebellum is popping up more and more. There's beautiful papers coming out. Now, when I read this paper last night, I'm like, hang on a minute, that doesn't match with what I read last week. And then I draw it out to see where I got wrong and realized it doesn't actually match. But as I said, I think there might be different schools of anatomy for the cerebellum. But I would need to go back to the original paper and see where the differences lie and what the difference in labeling then is. But they did write in the conclusion or discussion that according to their anatomical studies, the vermis is not morphologically distinct in the anterior part of the cerebellum, and that's why they label.
That's why they're empty, right?
I believe so. That's a jump that I make based on what's written, but they don't specifically state that in this publication. So that is probably discussed in previous work. But
is it possible that I mean, it's just one. I mean, we should look at another participant to see maybe some doesn't have distinct morphological difference from other structures, anterior part of the vermis, and others have, and they used one participant. So maybe that's also
correct. But then they draw that conclusion not only based on this single brain, but on the experience with previous cerebellar studies.
Okay.
But it's definitely worth having a look at the Schmahmann 1999 paper.
And what about, I mean, does anyone else have a question?
I think you stole everyone's question.
Sorry, I was faster.
I'm first serve.
About the fibers in cerebellum, what is the main problem? Why we still can't create an atlas of cerebellum? Why they didn't do that?
They don't, again, give a lot of details beyond the fact that they were very much interested in the surface reconstruction of the atlas. I guess because they based their digital atlas on the work of Sereno from 2020, I'm assuming that there may not have been diffusion data. Because if I go back to sharing the screen, so this is the original Sereno paper. This looks very much like, I zoom in a bit. T1, T2 imaging. Yeah, T2, T2, proton density. So there's no diffusion in here.
Yeah, okay.
And then this is the results of their work. Yeah, so it's not a matter of we can't, it just hasn't
They didn't have the data yet. Yeah.
Done at that level. Yeah. There's some beautiful work on the fibers of the cerebellum, but not as an atlas as far as I'm aware.
Okay. Well, thank you.
You're welcome. And then I mentioned, let me just show this to you briefly, but I also link it later. So we have this new anatomy playlist, and we actually have 2 talks dedicated to the cerebellum and the brainstem here. That might be of interest. They're shorter than our usual talks here, so only 12 minutes. And they also focus on the white matter because these are Klingler dissections of the cerebellum and the brainstem. But that could also be a nice resource to link with the paper. Hervé, you have a question.
It's not a question. It's not a question. I checked the website on the OSF, and it seems that the atlas is available. So there is a 2 GB file which I'm downloading now, but I don't have the file yet, so I cannot show you the. But yeah, seems to be a big file, so maybe the image is here.
Interesting. I don't see that. I downloaded the zip file, and when I opened the zip file, it only had the JSON.
But it seems, yeah, okay. So 2 GB of JSON is kind of
It's a lot of JSON.
okay. So yeah, just that.
Maybe I opened it too soon. It surprised me that it's not there. So happily stand corrected. But it'd be interesting to see and scroll through.
Eva has a question too.
Yes.
Yeah, I don't know how to do the hand thing.
I know Zoom changed over the summer.
But yeah, the number of the regions is not clear, but is it more clear why they do it by size?
Hang on, the number is clear. We have 32 regions that are subdivided into 815 parcels.
The 800, is that justified for some?
As in, we don't know if it's based on cytoarchitecture or what it's based on, but there's a distinct number, and what they describe in the method is that they made sure that they don't overlap those 815 regions and that they're of equal size. And you see them in the paper as well. If I go back and we go to the results.
But if they're equal size, they're probably not based on cytoarchitecture. Or
yes,
still.
What? But I may have gotten this wrong because I was missing a bit of detail. But I think the 32 regions are anatomically labeled, and then they subdivided those into equal parcels. And what you see here is that these dark lines, these dark lines, these are the individual subdivisions. And the colorful lines are the 32 regions.
Yeah. My question was, why make them all the same size? Or so we can study into individual variability later on, but yeah, why would they need to be the same size?
Yep, I have a question mark on that in the in the paper. That was not further specified. So there's a couple of statements in there where I would have liked a bit more of an explanation why they opted for choice A and not B, and how they did it in the end. But again, it's a preprint, so things can change.
Yeah, thank you.
And also, like, they have experts in the team, so I would trust the labeling to a certain degree, but I would still like a bit more detail, and also a discussion to other atlases or reports in the literature. Okay, seems this was all the questions that we had. In that case, we're finishing perfectly on time today. Thank you very much. Have an exciting week in science and see you next Monday. Bye.